In this lesson, we're going to learn how to solve right triangles. Solving a right triangle means that we are going to calculate all of the missing values, so all of the angles and side lengths that we don't already know. Depending on which pieces of information we are given will determine how we can solve our triangle. So one of the things that can be helpful is just having something to keep track of all the angles and all the sides, and we can start by filling in the pieces of information we know to start. So our right angle is angle C, so that's 90 degrees, and angle B is 56 degrees. Remember, in triangles we have a relationship where an angle and the side length across from it have a relationship, and so they have the same letter name, capital letter for the angle and lowercase for the side. So across from angle B is side length B, and across from angle C is side length C. So side length A is the one I know, that is 7. So this helps me to see that I need to solve for angle A and then side length B and side length C. So I can start solving for angle A. Once I know two angles, I can solve for a third angle in a triangle by just subtracting from 180. So all three angles in a triangle add up to 180. So I'm going to subtract the 90-degree angle and the 56-degree angle, and that will give me angle A, which is 34 degrees. And then I'll fill that in up here to know that I'm finished there. So now I need to find side length B and side length C. So I'm going to start with side length B. Now here we can pick either the angle A or angle B. It doesn't really matter. I'm going to pick angle B for my reference angle. At this point, what I do matters because opposite and adjacent are dependent on the reference angle that I'm choosing. So across from the right angle is the hypotenuse, and across from the reference angle is the opposite, and then the last side, the one beside the reference angle that is not the hypotenuse, is the adjacent. So now that I have those, if I need to solve for side length B, I need the O, and then the other piece of information I have is A, and I'm using B, the 56-degree angle. So O and A, if you recall, we have SOHCAHTOA to help us remember the three primary trig ratios. So the opposite and adjacent are the tangent. So the tan of angle B, which is 56 degrees, is equal to the opposite, which is B, over the adjacent, which is 7. So now I just need to move this 7. It's a division by 7, so the opposite of dividing by 7 is to multiply by 7. So 7 times the tan of 56 degrees is equal to side length B. And when we calculate that, 10.4 is equal to side length B. And then we'll fill that in over here just to keep track. Now to find side length C, we could at this point also use a primary trig ratio, or we can just use Pythagorean theorem to solve. So side length C, C squared is equal to A squared plus B squared. So A is 7 and B is 10.4. So when I square those and add them together, I get 157.16. Now to solve for C, I'm going to need to square root, and so side length C is equal to 12.5. And now I have found all unknown sides and angles, so we are finished here. Let's look at another example over here. So my starting point, I have side length C, side length B, and side length A. So I know A and B for side lengths are each 3, and I know that angle C is 90 degrees. So I need to solve for angles A and B and side length C. So I'm going to start by solving for side length C using Pythagorean theorem. So C squared is equal to A squared plus B squared. So that's equal to 3 squared plus 3 squared. So C squared is equal to 9 plus 9, which is 18. And then I'm going to need to square root that. Oops. To solve for just side length C. And the square root of 18 is 4.2. So now I have all 3 side lengths. The next thing I'm going to solve for is angle B, and it doesn't really matter what we solve for. So angle B here, and the 3 and the 3 are the opposite and the adjacent. So I can do the tan of angle B is equal to opposite over adjacent. So that's equal to 3 divided by 3, which is equal to 1. And then to solve for angle B, I'm going to do the inverse tangent. So that's how I move the tangent over of 1. And when I use my trig table or calculate that, 45 degrees is what I get for angle B. And then I'm going to solve for angle A, and because I know angles C and B, to solve for angle A, I'm just going to take 180 degrees, the total of all 3, subtract the 90 degree angle and the 45 degree angle, and I'm left with 45 degrees also for angle A. So I'm going to leave these for you to try. I will write in the answers over here so you can check your answers. So our starting point is we know that angle C is 90 degrees, and when you solve, angle A will be 50 degrees and angle B will be 40 degrees. And then I also know that side length A is 10 and side length C is 13. And when you solve for side length B, that should be 8.3. And then in the next triangle, we know C is 90 degrees and A is 49 degrees. And we know that side length 8 is across from A, so A is 8. So when you solve, angle B is equal to 41 degrees, side length B is equal to 7.0, and side length C is equal to 10.6. So you can try those 2 triangles and check your answers over here.